So now let's say if I put f equal to 1 kilohertz, then I'm going to get power equal to n naught by 2 because that's a constant value somewhere here. And if I put f equal to minus 1 kilohertz, again I get power of n naught by 2. So total power combined at f equal to 1 kilohertz, because in practice frequency cannot be negative. So the total power combined will be nothing but n naught, because n naught by 2 is available at 1k and n naught by 2 is available at minus 1k. So why we call it a white noise? Just because its PSD is constant. So in simple words, we say that this noise is present equally at all the frequencies. It is not similar to low frequency noise or high frequency noise. Low frequency noise is present at low frequencies. High frequency noise comes into picture at high frequencies. White noise is the noise which will be present with the constant amount of power at all the frequencies. Now this is valid up to the frequencies as high as in gigahertz. If you go beyond that, then you may see variations in the power spectral density, but most of the practical applications operate up to frequencies in tens of gigahertz. And for all those practical applications, hence my PSD of white noise becomes constant. So this is a major concern. This is a concern because generally one way to remove noise from the signals is by filtering or by changing the frequency of operation. In case of a white noise, even if I change the frequency of operation, the white noise will still be available with the equal amount because it does not depend upon the frequency. And hence white noise becomes a major source of noise in any communication system. What are the example of white noise? So we have discussed one noise, that is the thermal noise. Now thermal noise comes close to becoming a white noise. Thermal noise is also a noise which is present at almost all the frequencies with equal power spectral density. And hence sometimes thermal noise can simply be termed as white noise. Why we use the word white? Because like white color, which consists of all the fundamental wavelengths, because the noise is present at all the frequencies, we give the analogy of white color to this noise, and hence we give the name of white noise. The thermal noise, which was also called the Johnson noise, is sometimes also referred to as the white noise. If we find the probability density function of white noise, then PDF as we call it, the probability density of white noise is of Gaussian in nature. Gaussian function is a type of PDF. So if you define probability density function for white noise, it comes out to be a Gaussian noise. And because thermal noise qualifies to become a white noise, sometimes we also call thermal noise as Gaussian noise. So these are the various names used for thermal noise. So I repeat, thermal noise or the Johnson noise is the actual source of noise which exists due to the thermal energy, and they satisfy the properties of white noise because its PSD is flat or constant over a large range of frequencies, and its PDF is of Gaussian nature, so it also satisfies the second property of Gaussian noise. So sometimes thermal or the Johnson noise are also called white noise or Gaussian noise.